Welcome back to the Deep Dive. This is the show where we do the heavy lifting for you to give you that shortcut to being, well, truly well-informed.
And today we're moving past the usual, the daily feature announcements.
Right. Today we've got a stack of sources that, when you put them together, they paint a picture of an AI landscape that's really undergoing some massive structural transformations.
The intelligence we've gathered points to these systemic pressure points. We're talking about foundational challenges to how we educate, massive medical breakthroughs, and a really profound reevaluation of the American workforce.
Okay, so we've distilled all this down into 4 critical areas for you. We're going to kick things off with this really urgent and, I think, controversial call for schools to just surrender the fight against AI detection.
Then we pivot to a huge win for medicine, a new Harvard AI tool that is solving these long-standing, really heartbreaking, undiagnosed genetic disorders in kids.
And after that, we get into some pretty sobering data from MIT. It reveals this hidden iceberg of AI's impact on jobs, it's far bigger than the tech layoffs you read about.
And finally, we'll wrap things up with a more measured run-through of the big corporate and product updates that are really driving the whole market shift right now.
Okay, let's unpack this.
So let's start in the classroom.
Yeah, where the rubber meets the road for pretty much everyone. We've all been watching this high-stakes and, frankly, losing battle against AI-generated homework.
Right. And now one of the most respected voices in the entire field is basically saying it's time to stop trying to catch students, and instead you just have to change the rules of the game.
And that voice is Andrej Karpathy, former top researcher at OpenAI.
Exactly. And his stance is provocative, but it's technically sound. He called AI detection tools, quote, doomed to fail.
And his argument isn't really an academic one, is it? It's a technical one.
It's a pure technical reality. The models are just getting so sophisticated. He said very plainly that educators will never be able to detect AI use reliably.
Because the detectors themselves just don't work.
You don't work. That's his bottom line. And he points to a really specific, almost alarming example to prove it.
Which is what? What's the model that makes detection impossible?
It's a Google model called Nano Banana Pro. And this thing represents a huge technical leap. It can complete these highly complex exam problems correctly, which, that's the baseline now.
Okay.
But the crucial part is that it can now mimic a student's actual handwriting style inside the document it generates.
Wait, hold on. So an AI can master both the content, say, solving differential equations, and the unique, messy handwriting of a specific student.
Precisely.
Then detection becomes, it's completely moot. You're just policing a piece of paper, not where the sock came from.
Exactly. And that leads right into his big proposal. He says the education system has to move the entire axis of evaluation.
Meaning what?
Meaning they have to shift basically all graded work to in-school settings. We're talking supervised essays, closed book tests, projects written under controlled conditions.
So a major move away from traditional take-home assignments where you just can't trace the AI's involvement.
You can't. It's impossible.
That feels like a necessary shift. But let's talk practicalities. For huge public school systems, moving all high-stakes work into the classroom, that requires massive logistical coordination, new staff, much higher costs.
It does.
So is Karpathy proposing an ideal solution that the system can't afford, or is this a mandatory one for survival?
He's framing it as mandatory for survival. The necessity, in his view, outweighs the logistical nightmare, because if you can't trust the assessment,
the whole credentialing system just falls apart.
The whole thing falls apart. But his other argument, the complement to this, is that outside of that controlled classroom, AI has to be embraced. It must be an essential learning companion.
So the goal of education has fundamentally changed. It's not about memorizing facts anymore. It's about how you synthesize information and apply it under pressure without the tool.
That's it, exactly. Karpathy lays out this new educational goal. Students must become, quote, proficient in the use of AI, but, and this is the key part, they also have to be able to exist without it.
They need that core capacity for original, independent thought.
Which you can only test when the AI is taken away.
So while AI is creating all this dread in education, let's pivot to where it's delivering just undeniable life-saving clarity. We're heading to Harvard Medical School.
Yes, to look at their new AI genetic analysis tool, which is called popEVE.
And this is just a landmark positive application.
It really is. popEVE stands for Predicting the Evolutionary Visibility of Essential Variants. And the method it uses it's just brilliant in its simplicity. It doesn't just look at the human genome.
It uses comparative genomics. Explain that for us. Why does comparing my DNA to, I don't know, a jellyfish help solve a rare human disease?
Because it's analyzing mutation patterns across hundreds of thousands of species all across the evolutionary tree. So if a specific gene variant is found in lots and lots of healthy organisms,
Then evolution has basically certified it as harmless over millions of years.
exactly. But if a variant in a human is not seen in any of those massive databases of healthy genomes, it suggests nature has selected against it for millennia.
Because it's likely harmful
Hmm.
or even lethal.
Right. It's a phenomenal filtering mechanism. It ranks the danger of a variant based on evolutionary history, then calibrates it against databases of healthy humans just to confirm.
And the results, the impact.
The immediate impact was just stunning. Researchers applied popEVE to a group of 31,000 children. These were kids with severe developmental disorders that traditional genetic testing just could not solve.
And popEVE found answers.
It provided a concrete diagnosis in roughly 1/3 of those previously undiagnosed cases.
Okay, here's where it gets really interesting for me. Because this tool isn't just diagnosing things we already knew about, it's revealing entirely new biological insights.
Absolutely. The analysis flagged over 120 genes that had zero prior connection to these conditions. This is literally expanding the known boundaries of human rare disease.
And those findings are holding up.
In the short time since the study, 24 of those newly identified genes have already been verified by outside scientific teams as being causative.
That's a massive expansion of knowledge. But let's talk accuracy. I mean, we know there are other powerful models out there, like DeepMind's AlphaMissense. How does popEVE stack up?
It cuts down the noise, which is so critical for doctors trying to give families a definitive answer. AlphaMissense, it's powerful, but it flags 44% of healthy people as potentially carrying dangerous variants.
That's a huge rate of false positives.
A huge rate. It just gums up the whole clinical process. popEVE drops that number dramatically. It flags dangerous variants in only 11% of healthy individuals.
So that accuracy makes it profoundly more useful in the real world.
Exactly. It helps get real diagnoses into practice.
Truly an incredible application. Okay, let's transition now from medical diagnosis to economic prognosis. MIT has published what feels like a sobering reality check on AI's true effect on the labor market.
Yes, they're introducing what they call the Iceberg Index, and it's a labor simulation designed to look past the headlines.
Because when most people think about AI and jobs, they think of the tech industry, right? They see the layoffs in Silicon Valley and assume that's the whole story.
And MIT is saying those layoffs are just the 2.2% tip of the iceberg.
So break that down. How did they calculate the size of the whole thing?
They modeled 151 million American workers across 32,000 specific skills. I mean, a comprehensive map of the U.S. labor market. Then they measured where current AI can substitute for human job functions.
And what did the simulation show?
It showed that AI can currently handle tasks worth a staggering 11.7% of total U.S. wages.
Let's put that in dollar terms just to grasp the scale.
Okay, so the tech layoffs you read about, the tip that represents about $211 billion in wage exposure, but the hidden automation potential, the main body of the iceberg, that's in office and professional roles. And it's estimated to be as high as $1.2 trillion.
That's a colossal difference. And that explains the name. The most dangerous parts are underwater, completely unseen by the headline.
Exactly. And the most exposed sectors aren't tech. It's roles like HR, logistics, and finance. They show nearly 10 times the exposure risk.
Why those sectors specifically? What tasks are being automated away?
It all comes down to predictability, high volume, repeatable tasks. So in finance, think data validation, generating reports, invoicing. In HR, it's that initial resume screening or scheduling. In logistics, it's complex route optimization.
So the middle tasks of white-collar work, the structured, predictable stuff, that's a prime target for AI deployment.
Prime target. And this completely reframes the labor discussion. It's not a localized coastal tech problem.
Right. The data showed a big geographical shift.
A huge one. Manufacturing and logistical states, they called out Tennessee, North Carolina, Utah, they register very little tech layoff impact, but they face the widest gaps, the biggest potential automation risk.
And are they acting on this?
They're already using this MIT data to test workforce policy scenarios. They're trying to prepare for what's coming.
So if we connect this to the bigger picture, this isn't about coders. The $1.2 trillion displacement is a national administrative problem hitting our most critical infrastructure sectors first.
It's a stark warning that policy needs to catch up immediately.
Okay, let's shift gears now. We'll cover some of the other crucial news from the AI landscape, and we'll take this at a slightly slower, more measured rhythm to capture some of the details.
Starting with what's new at OpenAI, focusing on core usability.
Right.
So they just introduced a seamless voice mode integration, and it's directly inside ChatGPT's chat threads now. This might seem minor, but it's a huge improvement for user experience.
Because you don't have to switch to a separate mode anymore.
Exactly. You can just use voice input right where you are. It feels native, immediate.
We're also seeing some interesting new applications in entertainment aimed at very specific demographics.
Yes, Character AI just rolled out a new feature they're calling Stories. It's an interactive, AI-powered choose-your-own-adventure experience. And they've specifically designed the framework to create safe content formats for teens, focusing on engagement through collaborative storytelling.
And we're also seeing those big non-tech companies starting to restructure to find the savings that the MIT Iceberg Index predicted.
A perfect example is HP. They just announced a major internal restructuring plan, which includes cutting between 4,000 and 6,000 jobs, and they explicitly tied this to the industry-wide AI shift.
And the savings.
They're projecting it will just rate about $1 billion in savings by 2028.
Now, turning to projections, OpenAI has set itself a pretty staggering growth target.
Staggering is the word. Their internal projections are that ChatGPT will reach 220 million paid subscribers by 2030.
220 million, to put that in perspective.
That would place their subscriber count right alongside global giants like Netflix and Spotify. It shows their ambition is to become a utility, something as common as a streaming service.
And finally, on the oversight front, it looks like governments are ramping up scrutiny.
Very much so. That's why Anthropic CEO Dario Amodei is scheduled to testify at a House of Representatives hearing. And the topic is serious. It's about the company's recent discovery of an AI cyber attack that used their own model, Claude Code.
Which just underscores the immediate need for a governmental review of these security risks.
No question.
Okay, moving on to our final segment, let's highlight the specific tools that are really defining the cutting edge right now, the ones setting the benchmarks.
These are the frontier models that are setting the pace for everything we've been discussing.
First up is Claude Opus 4.5. This is Anthropic's new benchmark topper. It's defining what state-of-the-art even means for large language models at this moment.
And then you have Google's new image AI, Nano Banana Pro, which we talked about earlier. It's getting so much attention because it has finally cracked the code on rendering high-quality text inside a generated image.
Which was a huge stumbling block for older visual models.
A huge one. Google is also pushing hard with Gemini 3, their top-ranked model, which is noted for its really advanced multimodal capabilities.
Meaning it's not just text.
Not just text. It excels at integrating and understanding information across images, video, and audio all at the same time.
And finally,
keep an eye on FLUX.2. That's from Black Forest Labs. It's a new visual intelligence model that's contributing to the really fierce and rapid advances we're seeing in image and video generation.
So that brings us to the close of today's deep dive. We've covered the need for huge structural change in education, the incredible life-changing promise of a tool like popEVE in genetics, and of course, that urgent economic reality that the MIT Index brought to light.
So what does this all mean for you?
Well, the synthesis of everything we looked at today raises, I think, a really essential and provocative question for you to consider.
Given Karpathy's assertion that students must be proficient in AI, and the MIT data showing $1.2 trillion in wages are exposed, is the current speed of institutional change in our schools, in state policy, in corporate boardrooms, is it fast enough to prevent a major labor disruption?
Or is the education system and the policy world still just playing catch-up to a workforce reality that is already here?
That tension between how fast technology is moving and how slow institutions are to adapt? That's the defining challenge of right now.
If you found these insights valuable, please make sure to follow the deep dive and share this with anyone you know who needs to stay ahead of the curve.
We'll see you in the next deep dive.